Hello, today I'll be going over 7.3 and 7.4. Here are the important theorems for 7.3. The first one is if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So that means there's three total triangles that are similar. So that would be this one here, the small one here, and the big one there. So those are listed out in the theorem if it's helpful. So all of those are similar. Okay, next, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the lengths of the two segments. So if we write BD, which is this section here, over CD, that's going to equal CD over AD. Okay, and then the next one, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the leg of the right triangle is the geometric mean of the length of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. Okay, so we have AB, so that's this entire length, over CB, is equal to CB over DB. Oops. So this little piece right here. Sorry, I'm trying to make it dark. Okay, hopefully you can see that. And also AB, which is this entire length here, over AC, which is this length, here, equals AC over AD, which is this one here. So you'll just kind of have to figure out what you're given and then which of these proportions to use. Okay, so number one, we want to identify the three similar right triangles. So let's start with the big one, MLK. That is this one here. And that is going to be similar to. So I started with the right angle. That means I have to start at the right angle when I list out the other ones. So we have this one here, which would be NLM, and the last one, which is this one here, and this would be NMK. So all three of those are similar. Okay, next we want to write a similarity statement and complete the proportion. So for the similarity statement, that would be all three triangles again. So we have the big one. We have GEF. That's going to be similar to GEF. Okay, so that'll be HEG. And that's similar to HGF. Okay, so in this problem we have EF, which is this length here, over EG, which is this length here, is equal to EG over something. So if we go back to look at the proportions that we have for the theorems in theorem 7.6 and 7.7, it would be this one here. So this would be since it's not using the altitude, it's using this one here. So if we compare it, we have EF, which is the big piece. So that's like AB here, over EG, which is CB in this problem. So that means we want to find DB for our triangle. So for this, it would be EH. So this would equal EH. Okay, number 3, we want to find the values of the variables. So all of these are going to be using the theorems, and you'll just have to know how to set them up. Number 3, our x value is the altitude, so we're using 7.6. So we can set this up as 4 over x equals x over 9. And then to solve, we're going to cross multiply. So we get x squared equals 36. And then we're going to square root both sides. So we get x equals 6. Okay, number 4, we're not using the altitude, so we're using the geometric mean leg theorem. So this would be 8 over x. So the big length over x equals x over 6, since this piece here would be 6. If the entire length is 8 and we know part of it is 2, that means the other side is 6. So when we cross multiply, we get x squared equals 48. And then we can square root both sides. So 48 would break up into 8 and 6. 8 breaks up into 2 and 4. 6 breaks up into 2 and 3. And 4 breaks up into 2 and 2. So we have a pair of 2's here and a pair of 2's here. So those 2 can come out of the radical. And we have a 3 that will stay on the inside. So 2 times 2, we're going to multiply whatever can come out. That will equal 4, so it'll be 4 rad 3. Okay, number 5, we're using the altitude. So this setup would be b plus 3 over 6 equals 6 over 8. So we're going to cross multiply. We'll get 8 times b plus 3 equals 36. So that'll be 8b plus 24 equals 36. And then subtract 24. So we get 8b equals 12. And then divide by 8. And we'll get 3 over 2. Because we can divide all the numbers by 4. Okay, and then next we have this problem we want to solve for x and y. So to find x, this would be x over 12 equals 12 over 16. Oops. So we're using the altitude. So we get 16x equals 144. And then we're going to divide by 16. And we get x equals 9. Okay, next to find y, we have 25 over y equals y over 9. So we know that this part is 9, and that means the entire length is 25. So that's where I got those numbers. So y squared equals 225, and we get y equals 15. And the last one, to find z, we have 25 over z equals z over 16. So z squared equals 400, and that means z equals 20. Okay, and then for 7.4, this is kind of a short section. So there are two special right triangles. So I'm just going to draw two triangles here. So if these two angles are 45 degrees, that means across from them would be x, and the hypotenuse is x rad 2. And for the other triangle, we have a 30, 60, 90 triangle. So across from the 30 would be x, across from the 60 would be x rad 3, and the hypotenuse is going to be 2. So you want to find the value of each variable and write the answer in simplest radical form. So for number 1, since both of these are the same, they're both phi rad 2, that means we're going to be using the 45, 45, 90 triangle. So just to not confuse like the variables, I guess, we can think of, we can think of this as like, okay, so this is x, right? Like this is this part. So x in the problem would be that times rad 2. So this would be 5 rad 2 times rad 2. So that'll be 5 times 2, which is 10. For number 2, we have this triangle here. So this is going to be a 30, 60, 90 triangle. And we want to find x and y. So for this problem, this would equal 2x, right? Because it's the, this should be 2x. Because in the 30, 60, 90 triangle, this should be 2y because y is the side across from 30. So that means we can find what y is. So that would be 2y equals 12 rad 3. And then we're going to divide by 2. So we get y equals 6 rad 3. So y is 6 rad 3. And x is going to equal y rad 3. So x would equal 6 rad 3 times rad 3. So that's 6 times 3, which is 18. Okay, next we want to find r and s. So if the entire bottom is 18, that means this part is going to be 9, this part's going to be 9. And here's 30 degrees and 30 degrees, since we know the other two are 60 and 90. So for r, that's going to be 2 times 9, because it's 2 times the side across from the 30-degree angle, so it's going to be 18. And for s, that's going to be 9 rad 3, because it's rad 3 times the side across from 30. Okay, and then here's the last one. So it's another 30, 60, 90 on the top and a 45, 45 on the bottom. So the only number we're given is in the 30, 60, 90, so I'm going to start in that triangle. And we know that 9 rad 3 is across from the 60. So that means E, which is across from the 30, would be 9 rad 3 over rad 3. So if we divide it by rad 3, we'll get what E equals, which means E equals 9. And F is going to equal 2 times E. So that means this is 18. So this is 9, this is 18. And then for G, that means we have to divide the hypotenuse, which is 18, by rad 2. So 18 over rad 2 would be G. Okay, that's it. Hope you